old is the universe. It may be up to twice as old as previously thought. The universe may be much older than current estimates suggest. According to theoretical physicist Rajendra Gupta of the University of Ottawa, the universe is 26.7 billion years old, not 13.8 billion years old. Our newly developed model extends the formation time of galaxies by several billion years, making the universe 26.7 billion years old, not 13.8 as previously estimated, says Rajendra Gupta. This may explain why the most distant galaxies we've observed look surprisingly mature, although according to current estimates, they should have been around for only 500 million years. Gupta's work was published in the journal Monthly Notices of the Royal Astronomical Society. Astronomers in the 19th century noticed that light, the source of which lies at a considerable distance from the Earth, is redshifted. This phenomenon consists in a shift towards longer wavelengths of the lines of the spectrum of electromagnetic radiation. This measurement is used in astrophysics, e.g., to estimate the age of the observed objects. Light takes time to travel through space. A greater reddening effect is observed for more distant objects. The most likely explanation is that space is expanding, stretching the waves of electromagnetic radiation. And since it expands, it must have started somewhere and sometime. Thus, light from objects farther from Earth is older than light from objects closer to Earth. Going backwards, based on the estimated rate of expansion of the universe, one can estimate when the Big Bang occurred. In 2021, using the lambda-CDM cosmological model and combining various techniques, the age of the universe was estimated at 13.797 billion years. However, there are objects in the cosmos whose age seems to be comparable to or even older than the estimated age of the universe, such as a star called Methuselah. The James Webb Space Telescope recently discovered early galaxies that existed only 300 million years after the Big Bang. They seem mature, as if they have gone through billions of years of evolution. An alternative explanation of the relationship between redshift and distance was proposed in 1929 by Fritz Zwicky. According to him, If photons lost energy over time due to collisions with other particles, more distant objects would appear redder than those that are closer. Zwicky himself admitted that any scattering of light blurs images of distant objects more than what can be seen. But Zwicky's concept, sometimes referred to as tired light, ran into a lot of problems and was not supported by observations, so it remained on the margins of astrophysics. Gupta dusted it, according to him, by allowing this theory to coexist with an expanding universe. It becomes possible to reinterpret redshift as a hybrid phenomenon, and not solely due to expansion. Gupta combines Zwicky's work with that of French Nobel Prize winner Paul Dirac, who suggested that the physical constants that govern interactions between particles could change over time. By allowing the solids to revolve, the formation timeframes of early galaxies, as seen with the Webb telescope at high redshifts, can be extended from a few 100 million years to a few billion years. This provides a more realistic explanation for the advanced level of development and mass observed in some ancient galaxies. Furthermore, Gupta suggests that the traditional interpretation of Albert Einstein's proposed cosmological constant, which represents the dark energy responsible for the accelerating expansion of the universe, needs to be revised.